what we're looking at today is the zero product property. And I know that there's a lot of example problems on the note sheet. We're not going to go through every single one. We'll go through a good number of them, but I feel like once y'all get the hang of it, it's going to make sense. The zero product property states if the product of two expressions is zero, then one or both of the expressions must be zero. Well, if I multiply two things together and it equals zero, well, what's the only number I can multiply by something and get zero? Zero, right? Because zero times anything is zero. So if I say I have two things that multiply together and equal zero, one of them has to be zero. That's the zero product property. And that is one of the key things with quadratics or any higher degree polynomial function. Because if I can write it as multiple things being multiplied together and they equal zero, well, one of them has to be zero. Whenever we're solving quadratics or higher degree polynomial functions, we're wanting to know what is the value of x that makes the function equal zero. That's what we're wanting to find. So the first one we're looking at is this here. K plus 1 times k minus 5 equals 0. Well, I do have two things being multiplied together to equal 0. So either k plus 1 is 0 or k minus 5 is 0. So we're saying that either k plus 1 is equal to 0 or k minus 5 is equal to 0. Because if the two of those multiply together to equal 0, one of them has to be 0. Solve. To solve for k, we would. Yeah, we minus 1 telling me k is equal to -1. Here we would add 5 telling me k is equal to that's it. The solutions for this here is that k is equal to -1 or k is equal to 5. Now there is one case to where the values of x or the variable will be the exact same, and that's really if the two things in parentheses are the exact same. Because if it was k plus 1 times k plus 1, then k would equal -1 and k would equal -1, then it would be the same. But that's the only time where we'll have it be the exact same value. Otherwise, it's going to be one or the other. Because either it's at -1 or 5. Both of these will work. Because again, we're talking about a quadratic function, which we've seen already multiple times as a U-shaped graph. Where it crosses the x-axis, it'll cross in two spots. These are the places where it crosses. Questions on this here? 2m plus 3 times 4m plus 3 equals 0. Well, according to the zero product property, one of these must be 0. So we're saying that either if I can write, 2m plus 3 is 0 or 4m plus 3 is equal to 0. One of these would be 0 because of the zero product property. Anytime we have two or more things multiplied together to equal 0, one of them must be 0. So we would do what first? Subtract the 3 from both sides, which will tell me that 2m is equal to -3. And from here we would divide both sides by 2, which tells me m is equal to -3/2, or -1.5, or any other way to express that. Well, we do the same thing to the other side, solve for the value of m, so we would subtract 3 from both sides, which tells me 4m is equal to -3. Divide both sides by 4, which tells me m is equal to -3/4. And that's it. Any other questions on this here? All right, let's look at the next one. Here we have x squared plus 10x plus 21 equals 0. Do we have two things multiplied together? Well, no, because we've got three things being added together, added or subtracted from each other, yes? Well, here they're all being added. Wait a minute, the last 2 days, haven't we been going over a way to rewrite this quadratic as a set of two parentheses being multiplied together when we factor it? So let's factor it. Is there a greatest common factor between all three terms? No, so we will have two parentheses with three spaces, and this is still going to be equal to 0, because we're not changing the equation or how it's working on either side. We're just rewriting that quadratic in a different form. Now the next step was our signs. Since the third term is positive, the signs are the same and they match the sign of the middle term, which is also positive, so we'll have plus and plus. What are the factors of our first term? X and x. The factors of the third term, we have 1 and 21 or 3 and 7. Which one do we want to use? 3 and 7. Thank you. 3 and 7. Now, on probably some of the ones we've been doing before, when we write it out, we kind of put the check step underneath. Are we going to finish once we check this? Well, no, we still need to solve it. There are steps below it. So when I'm solving or doing that, I do the check somewhere off to the side. So if you've noticed on the ones I've done previously, I always like to write the check above it or off to the side. That's why. So that we have space to continue solving the problem. So here when we check, x times 7 and 3 times x, well, x times 7 is 7x, plus 3x equals 10x. Is that what we wanted? Well, hey, now do I have two things multiplied together that equal 0? So we can solve. So we could say that x plus 3 is equal to 0, or x plus 7 is equal to 0. For the x plus 3 to solve, we would subtract 3 from both sides, telling me x is equal to -3. Or here we can subtract 7 from both sides, so x is equal to -7. And that's it. That's all we have to do for this here. Any questions on this here? Are we ready to look at another one? Yes? Let's look at this one here. So we have 4x squared plus 20x minus 24 equals 0. So what would we do first? Greatest common factor, is there one? 4. So I can factor the 4 out. 4 factored out of 4x squared would be x squared. Plus 4 factored out of 20x would be 5x. Okay, so we factored the 4 out and got 5x, and when we factor 4 out of 24, we're left with -6 is equal to 0. Okay, so we have this here, 4 times x squared plus 5x minus 6. So we can go on and factor this down, 4 parentheses. Here. Now, since the 6 is negative, our signs are going to be opposite. One is going to be positive, one is going to be negative. Because whenever the third term is negative, the signs are opposite. Now we need to find the factors of x squared and 6. Well, the factors of x squared are x and x. And the factors of 6 are what? 1 1 and 6, or 3 and 2, or 2 and 3. So which one do we want to try first? 1 and 6. And again, we can check this here to see, will this give us the middle term of 5x? Well, x times negative 6 would be negative 6x. 1 times x would be plus x. So negative 6x plus x would be negative 5x. Is that the middle term we wanted? We need to switch the signs so that the 6 would be positive and the 1 will be negative. So that would be correct. So 4 times x minus 1 times x plus 6. Right? Okay. So what do we do next? So any two things multiplied together equals 0. One of them must be 0, yes? What about the 4? Right, because 4, well, 4, can I ever make 4 0? Just by messing with 4? Well, no, because 4 is just a number, right? We can only affect the variables, what we plug in. So does the 4 really matter at this point? No, we can ignore it, because we're really just looking at x minus 1 is equal to 0 and x plus 6 is equal to 0. We're mainly looking at these two. Because if x minus 1 became 0, well, the rest of it's going to be 0 because we're multiplying it. So at this point here, we can add 1 to both sides, which tells me x is equal to 1. And over here, we would subtract 6 from both sides, telling me x is equal to negative 6. And that's it. That's all we have to do for this here. Any questions on any of this here? We ready for the next one? Now this one here is interesting, and we'll look at this later. And when I say later, I mean when we get to it again. It'll come up later. There was a reason I put it up there, but I'm not going to bother with it today because we will cover it again. Any other questions on what we did to factor these? Do we feel comfortable with solving this here? Yes. Because we'll be factoring doing the same thing we've been doing. So let's move on and look at this one here. Because the rest of them is pretty much we find greatest common factor, 2 sets of parentheses, sign, first factors of the first term, factors of the third, check, and solve. What is different about this one here? Right, the middle term's on the other side. It's not equal to what? 0, because in all the rest that we've looked at so far today, they've been equal to 0, yes? And our zero product property says if any two things multiplied together equal 0, one of them must be 0, yes? So what do we need this equal to? 0. There's 2 ways we can move it. We can get it equal to 0. Is I can add the 9p to both sides, or I can move the 3p squared and the 120. Which direction do y'all want to go? You want to move everything to the right or move everything to the left? Yeah, I mean, I would move everything to your left by adding 9p, because if I want to go the other direction, I'm going to have to subtract the 3p squared and add the 120. I'm going to have to do 2 moves to get everything that direction. I only have to do 1 move to get it the other way. I will tell you this, no matter which direction you move things, you're still going to get the same answer. as long as you don't change anything. Like at this point, if you added the 9p and the 3p squared, it would give you a different answer because those are not like terms. But when we add 9p to both sides, well, 9p plus negative 9p is 0. Here we would have 3p squared plus 9p minus 120. Rewrite that so I have a little more space. We'd have 3p squared plus 9p minus 120 is equal to 0. We added it to both sides. So now everything is on the same side and it is equal to 0. What can we do next? Do what? We need this equal to 0. We need it equal to 0. So we have it set up in the form we need. Greatest common factor. Now, the greatest common factor we used last time was 4, right? Did we do anything with the 4 at the end? No. So I could factor it out, or I can divide every single term by 3. Because this here, the greatest common factor when we talk about quadratics or higher degree polynomial functions, it is what we call a scalar. It's making everything else bigger or smaller. It's almost the same as our vertical stretch or vertical shrink, that amount. Did the vertical stretch or vertical shrink ever affect the vertex? Well, no, because the vertex stayed the exact same. It was just moving it up, down, left, right. It just changed every other point around the vertex. The scalar will change everything around our solution points, the x-intercepts. It won't change the x-intercepts. So we can divide 3 out of everything. 3p squared divided by 3 is just going to be p squared. 9p divided by 3 is going to be plus 3p. 120 divided by 3 is going to be minus 40 is equal to 0. So if we have a scalar in all of them, we can divide it out. Now, if it's not in all of them, I wouldn't do that, because if I went on and tried to divide again, I might have some fractional answers. Now, we can do this with numbers. We cannot do this with variables, because if it had a greatest common factor of p across all of them, we can't pull that out, because if I divide everything by p, we're removing a solution from the equation. If we divide by a variable, we're removing it from the equation. So if there is a greatest common factor of p or a variable, we do have to factor it out. But with scalars, if it's just a number across all of them, we can divide it out and be just fine. But if it's a variable, we cannot do that. But since it's just a number, we can. Now we can move on to the next step, our 2 sets of parentheses with 3 spaces. Now, since the 40 is negative, the signs are going to be opposite, because whenever the third term is negative, our signs are opposite. When the third term is positive, the signs are the same, and they match the sign of the middle term. Now, the factors of p squared are going to be p and p. Okay. Factors of 40. We have 1 and 40, 2 and 20. 3 doesn't work, but 4 and 10. 5 and 8. And that would be it, because 6 doesn't work, and we've 5 and 8. Which one do we want to try first? Five and 8. And we can check it. P times negative 8 would be negative 8p. 5 times p is going to be plus 5p. And negative 8p plus 5p is going to be negative 3p. Did we get what we wanted? Almost. We just got the wrong signs. So the 8 needs to be positive, and the 5 needs to be negative. So this right here is the correct setup, p minus 5 times p plus 8. Now at this point here, we do have two things being multiplied together and equaling 0, so we can set them both equal to 0. So either p minus 5 is equal to 0 or p plus 8 is equal to 0. So we can solve for each one. So here we would add 5 to both sides. So p is equal to 5. And here we would subtract 8 from both sides. So p is equal to negative 8. And those would be our solutions. And that's it. That's all we have to do for this year. Any questions on this? Do we feel comfortable with this here? Not as bad as y'all thought this was going to be? Do y'all need to see this one here? Okay. This one here would be the same thing. Y'all want to look at this one here. Okay. Okay. That's perfectly fine. I don't mind working on these here. Now, when we look at this here, we do have the 7n by itself, yes? So we can move everything over to the 7n squared, or we can move the 7n squared over to everything else. Which direction do y'all want to move? Move the 7n squared over? Yes. And to move it, we'll have to subtract 7n squared from both sides. Well, 7n squared minus 7n squared is 0. Now over here we would have negative 7n squared plus 14n plus 21. Now again, just like we covered yesterday with factoring, I don't like having the n squared being negative. So we can multiply or divide by -1. We can factor it out. Whereas we just saw, since it's just a number, we can divide everything by -1. It would work the same thing. But is there a greatest common factor? 7, yes? So I could factor out or divide everything by -7. Well, 0 divided by -7 is 0. -7 divided by -7 is positive n squared. -14 divided by positive 14 divided by -7 would be -2n. And positive 21 divided by -7 would be -3. That works just fine. Well, now we can factor, so we would have two sets of parentheses with 3 spaces, and this here is still going to be equal to 0. I'm going to get ahead of you. No, the side at which we put equals 0 really doesn't matter, because it's still saying that this is equal to 0 on the left or right side. I just have a tendency of wanting to have it on the right-hand side. That's just out of habit. I just feel weird having it over there. The next thing we would do is our signs. Since the third term is negative, we would have a positive and a negative. The signs would be opposite. The factors of n squared are n and n. Well, the factors of 3 are 1n. Do y'all have a preference on which one we put where? Well, we'll be able to check it, right? 1 and 3, 1 or 3, which one do you want positive, which one negative? What? I would go this direction here. Now we said yesterday, Addison pointed this out, that really since n's are both 1, we can really add those together. And what kind of number are we looking or wanting to get? We're wanting a -2, yes? So 1 minus 3 is -2, yes? So most likely we'd want the bigger number to be negative since we're just adding them together. I mean, the same thing logic works with, especially if we had 2n and 3n. Which one's more likely going to give us the bigger number? That one we might want to have negative. And if we do check this, n times -3 would be -3n. 1 times n is plus n, which gives me a -2n that I wanted. Now at this point here, we have two things multiplied together to equal 0, so one of them must be 0. So either n plus 1 is 0 or n minus 3 is equal to 0. So on this one here, we would be subtracting 1. Here would be adding 3, telling me n is equal to -1 or n is equal to 3. Throw that on the floor. Any questions on any of this here? Any questions on anything we've done so far? So we feel comfortable with this here. This one here. Is this any different? We would be combining those like terms when we move it. Because again, one of the things I will tell you here for this chapter, and really when we start talking about higher degree polynomials, meaning the biggest exponent won't be 2. We could have 3, 4, 5, 7, 12. Whenever we're solving those, we want it to equal 0. There are a few exceptions, but we'll cover those specifically when we hit them. But it's also will work just fine when we get it equal to 0. We want it equal to 0. So, but that's it. That is all we are doing today. So, I do have the worksheet here for y'all. Yes. We would subtract it from both sides, get it equal to 0, and then follow the exact same steps. So problem number 3 is what? On the worksheet, the front, problem number 3. Can y'all read that? 5x minus 30 equals 0. Number 4 is 2k squared minus 5k minus 18 equals 0. I think the only one that's kind of hard to read is
Aaron Holt, please come to the office. Aaron Holt.
Number 5, which is 3r squared minus 16r minus 12 equals 0. I've also uploaded this thing to Google Classroom, so
3r squared what? Minus 16?
Where I rewrote them back out. So if you lose it, it's there. Or if someone else is asking. So it is posted up there and you can actually read them all. Because I did go back over it with a different color. For some reason, the printers we have now dislike certain ink colors. So it's refused to print it in a little darker than that.